Okay, so we need to pick a side. It doesn't matter which, but this one looks more complicated. So I'm going to use this to get to here. You can choose any side you want, but sometimes one side is almost impossible to get to the other side. So it's best to choose the more complicated. All right. Now, they both have a 3 in common. We can start by factoring that out. Right. Let's see what we can do here. Before we bring in the identities from that PDF. Right, we should know from the formula sheet that sine squared theta is equal to 1 minus cosine theta, and cosine squared theta is equal to 1 minus sine squared theta. So maybe we can replace one of these guys with one of those. I'm going to try, over here I see a cosine. So I'm thinking we should change this to a cosine. That way all we have is cosines. Let's see if that works. Now, notice there's no like specific path to take. You just need to try something. And if you notice you're going in the wrong direction, or you feel like it's not making any sense, start over and try a different idea. Okay, sometimes I run into that problem myself. I'm like, you know what? The path I took may work, but it's turned into 10 plus steps. So maybe there's a better shortcut. And being able to see the shortcuts is experience. So I can't really help you there. So what I recommend is keep practicing, but also just try something. Like I just did here. I just tried that because I saw cosine and I know these are Pythagorean identities, or they can be applied to squares. That's what I was thinking. That's the thought process. Okay, so now distribute the negative, and we get cosine squared beta minus 1 plus cosine squared beta. Okay, so that'll be 3 times 2 cosine squared beta minus 1. Distribute the 3, and you get 6 cosine squared beta minus 3. And that's what we wanted to show, right? We wanted to get there. So we have proved that they are equal. We have verified the identity. Any questions on any of these steps? So all I did was factor, introduce the Pythagorean identity, and some algebra. Excuse me. Yes, cool. Number 3.
So far, so good.
Okay, let's move on to something with fractions because people seem to struggle with those the most. Okay. Example 4. Problem. Now, one moment. Oh, here it is. Found it. 2 over 10 is, yeah, 7. Sorry. Getting distracted today. 2 over 10x plus 2 over co-10x is equal to 210 times, oh, plus 2 co-10. All right. Right, so let's let's start with the left-hand side. So always write down what you're going to start with. Now we got to get to there. So there's quite a few different ways we can get there. The homework is kind of giving you a hint to go some specific route, but I'm not going to worry about that. Oh, I see what they did. Yeah, they're adding fractions, which is fine. Well, we'll do it their way. Then I'll show you a different way. So we have a fraction plus a fraction. So we need to introduce the LCD, right? So this will be 2 over, so LCD would be tangent times cotangent. Okay. So I need to multiply this one by cotangent x over cotangent x plus, so this guy's going to need a tangent, right? I'm just getting the same denominator. That's all I'm doing, just like any old fraction. So this would become 2 cotan x over the LCD, tan x cotan x plus 2 tan x over cotan x tan x. Okay, so then that would be 2 cotan x plus 2 tan x over the same denominator, right? Oops, fix that. There, perfect. So, remember on the first example, these cancel, right? And give you 2 cot10 plus 2tan, which is what we wanted to show, right? Just backwards, same deal. If you want to rewrite it, why not? Are there any questions on how to add these fractions? Was that okay?
Okay, I have a question. When you did the LCD, I don't even know. Wait, I'm confused.
Okay, so
Did just cotangent's the opposite of tangent? That's why you did the cotangent with the tangent?
it's basically like if you had a half plus a third, the LCD is 6, right? So you'd say, well, this one needs a 3 and this one needs a 2, right? Do you remember? So you get 3 over
Yes, sir.
6 plus 2 over 6. So I looked at these and said, well, the LCD will simply be tan times cotan. So this one needs a cotan. This needs a tan. Now they have the common denominators, which means you can add the top. Just like this would be 5, 6. Does that help? Or
And if it was like sine and cosine, it would be secant and cosecant.
no, if
Yeah, maybe.
let's say it was this thing's no longer wet. Let's say we had, I don't know, 1 over sine plus 2 over cosine. The LCD would be sine cosine, right? So you would have to multiply this one by cos and this one by sine in order to get this on the bottom.
Make it too complicated.
What's that?
So I'm just making it complicated.
Yeah, maybe. I don't know.
I get it now.
But you see what I'm saying, right?
Yeah, I
I have
get
a
it.
question, sir.
Mhm.
Yeah, on the last line, when you cross out the tan x and the cotangent x, what crosses them out? Because I don't see it there.
Oh, that was from here. Remember? We show that in detail right there. You see how they cancel?
Oh, from example 3.
Yeah, problem 3, example 1, we showed why. Because they're reciprocals of each other. So they end up turning into a 1. So I figured why show that again if we know right here, this will become a 1. So why even write it? There we go. Final answer. Okay. Any other questions? Is that a lot of people have issues with the fractions, so please let me know. Let's do another one with fractions. Let's do number 8 just to show you one more time. You guys cool on this page? Okay, let me know. Just let me know. Example 5. Problem 8. Okay, one plus sine theta over cosine plus cosine over 1 plus sine. Show that all this becomes 2 secant theta.
Oh,
Okay. Okay, so I'm going to choose the left-hand side. So looking at these denominators, what do you guys think the LCD is?
Sine, cosine.
What's down here?
Oh shoot. I need that.
All right, so the idea basically is if they're prime, you just multiply them together. That's all. That's all you got to do. Since 1 plus sine is prime and cosine is prime, the LCD is cosine theta times 1 plus sine theta. So this one will need a 1 plus sine introduced on top and bottom to maintain balance. This one will need a cosine, right? To create the LCD. Once they have a common one, we can add the fractions. That's the whole reason we're doing this. Okay. Is that okay? All right, so let's go ahead and multiply. Well, we're not going to multiply the bottom. We're just going to leave it as is because we're hoping something will cancel. So let's go ahead and get them together. 1 plus sine times 1 plus sine, you agree, just to keep it simple for now, is 1 plus sine squared. The denominator is now ready. Cosine theta times 1 plus sine theta plus cosine squared, right? Cosine times cosine over 1 plus sine times cosine. So there we go. Okay, so now they're the same and you can add them together. So we'll get 1 plus sine squared. Oops, sorry. 1 plus sine theta, entire thing squared plus cosine squared over the LCD because they have been added together. So if you struggle with this part, it's because your fractions are, you're rusty on your fractions. Okay, and don't feel bad about that at all. It happens. So far, all I did was add this fraction and this fraction. Is there any questions before we go to the next step? We have yet to do use any identities. We're just doing some fractions, and now we're going to do some algebra. 1 plus sine squared, if you FOIL this out, multiply this out, you're going to get 1 plus 2 sine theta plus sine squared theta. Okay. plus cosine squared theta. So I multiplied everything on top as much as I could. The bottom I will leave alone for now. You don't want to multiply unless you have to, because sometimes things cancel. The top part I had to because I'm hoping something will combine. Right, because if you notice, I need to end up with 2 secant. And I'm not really there yet. You see what I mean? So, is there any identities that you see at this current time on the paper? Well, you see that sine squared plus cosine squared, right? That's this guy. Sine plus cosine, if they're both squares, it turns into 1. Yeah, Pythagorean. So this becomes 1 plus 2 sine theta plus 1. Sorry, that was going to sneeze. Okay, so this became 1. So Pythagorean, first identity I used. Now 1 plus 1 is 2. Right? So I'm going to space here. I'm going to factor 2 out of the top. And I get 1 plus sine over cosine times 1 plus sine. So notice how these cancel, right? So now I'm left with 2 over cosine, which is the same. Let me rewrite this better. Which is the same as 2 times 1 over cosine, right? You agree with that? And this is on your formula sheet, secant. I think they call that the, I don't know if it's, yeah, they have it under quotient. Call it quotient or reciprocal, it's up to you. Any questions about those steps? I don't know if the homework question follow those steps, but it doesn't matter. We verify the identity. And that's what I want you to do. So see here, they're just having you fill in the blank. So I recommend trying to do it on paper first so you can learn the process. And then come back and see, okay, what the heck are they doing? Right, so what they did the same thing. Notice how over here they have addition and then they have the LCD. So they added fractions. So what did you get on the top? Well, that's what I had, right? 1 plus sine squared plus cosine squared. Multiply this out and they got this. That's what we had. Etc. Any questions on number 5, example 5?
Can you hold for just a moment, sir? I was writing it down.
Yeah, the one right here, or,
Yeah, that one. Thank you.
yeah, we're not turning the page yet. I'm gonna try to leave some for you because I did maybe about half of them. I need you to practice these. Let me see if I can find some in the book or something, so we can do a few more.
I'm good. Thank you, sir.
Okay. I think the exercises in the book are a little better. So let's do a couple of, or at least one of them for sure. Okay, I'm gonna pick this guy here. Cosine x plus sine x times tangent x equals secant x. All right, so let's start with the most complicated side. Okay, so the first thing I did was change tangent with the quotient identity. Is that the best way to do this? I have no idea. I just decided to try something and see how it goes. So tangent is sine over cosine. Sine times sine will give me something different. Sine squared over cosine, right? I forgot my x there. Now I'm going to add my fraction. Right now I have cosine x over 1, technically, plus sine squared x over cosine squared x. Multiply the top and bottom by the LCD. I don't know why I put a square there. So they both need, oh, this one doesn't need a cosine on the bottom. And do not need to change the other one. The other one's good. So that will give me cosine squared x over cosine x. Now that they have the same denominator, add them together. This will give us cosine squared x plus sine squared x over cosine. All right, so from here to here, I showed extra steps. I'm adding fractions. If you skip a couple of those, it's okay. But once you add them, you see that this is an identity, right? What is cosine squared plus sine squared? Yeah, that's gonna be 1. Let's see, Pythagorean. Pythagorean. And then one of our cosine is secant, right? Which is quotient. Any questions on any of those steps? All right, well, I'm gonna let you start doing those so you can bring me some questions next time. Let me see. Uh, Let me double check though. The best thing I can tell you, just some rule of thumb, I guess. If you see fractions, add them, because something might happen that will allow you to apply an identity. If you see squares, see if you can do a Pythagorean identity. See if you can replace a sine with a cosine or something weird, or maybe they combine and become the number 1. What else? If you see something that can be factored, like a number or a sine or a cosine or anything, see anything that can be factored, start by factoring. Those are things you should look for when you start. Look to see if there's a number or a term you can factor, and then look for fractions and look at the squares or something with powers. As you're doing this, you'll see those types of things will repeat themselves. Anyway, you guys have any homework problems that you're having issues with, or you guys doing all right? Because I think that's all going to be it for today. We're currently ahead of schedule, which is pretty cool.
Sir,
Mhm.
when is the next test?
Let's see here. Honestly, the next few sections are, well, this is the hardest section of test two, in my opinion. The rest are pretty formulaic. You just use formulas or plug in numbers. So those can go by pretty quickly. If we pace ourselves, I'd say, like if we really stretch it out, I'd say the exam would be will be due on Halloween. But if we go at the pace we're going now, we could probably take the test in a week or two. But we'll see. I'll get a better idea after, I guess after Thursday, depending if you guys have questions or not. If you don't, then I'll probably just start the next two sections.
Okay, thank you.
I'll give you an
Um,
estimate. I'll for sure give you a week notice because that's usually my goal.
And sir, did you hear anything about us getting like converted into a different class or like still needing to get nose swabs?
Just
Are
what
you-
just what I mentioned last time. They're not currently penalizing anyone, so I wouldn't. Yeah, I'm not really sure. I guess what I'm trying to say.